Okay, so I want to do a quick update today about the cryo heater. I'm working on two versions of this. One is a resistive heating, so just a nichrome wire wrapped around the well. This is a larger well, and the other version's a induction heater. But I'll talk about that one another time. Okay, right. So this one's, I mean, it's fairly straightforward, but it gets 500 watts. Um, it can provide 500 watts of heating, which is kind of a lot. So right now I just have it uh, set up. It's running through the microcontroller, so the microcontroller can control it. But this will just right. So this just signals the microcontroller to go ahead and do the heating. But next I'm going to work on the control of this. Okay, so I'm just going to push the button, and then you can see it gets to it's able to boil it. Um, yeah, so it works, pumps it in. Obviously, I'd never get it this hot. Uh, the tissue wouldn't do well, but it's just a good indicator to me. Um, Obviously, I can look at the thermocouple as well. Another just difficult issue was that the thermocouples with the exposed junction on the end are really nice because they have very low reactance time, like the thermal whatever insulation, the thermal resistance is very low because there's not extra covering around it. But even with and I use this ceramic adhesive that can handle the heat and to kind of hold the nichrome wire on. It has a very high electrical resistance, um, and um, and high thermal conductivity, which is kind of ideal. But the high electrical resistance, even with that, it's like, it's in the mega ohms, but it still, can allow some sort of voltage to present itself inside, in with the liquid. And even with distilled water, which obviously even with distilled water, but the cryogens would certainly not be, or the cryoprotectants would not be that that pure as pure water. It still messes with the thermocouple, the end of the tip of the thermocouple. So I don't know. There were different options. There's insulating sheaths, or sheaths that kind of protect it from whatnot. But I found actually a very simple thing that has very low thermal resistivity is the or resistance is just coating it in a little bit of silicone, and the silicone can handle the liquid nitrogen and the temperatures we need, and so that's been working really well. I've also worked on a stage for a whole setup for controlling the temperature for performing the experiments, basically. So I'll cover that in another time. Okay, that's it for now.